So let's look at the last part 3. You're told not to use calculator for this part here. So the distance between 2 points along a curve is the arc length. Scientists and engineers need to use arc length in applications such as finding the work done in moving an object along the path described by the curve. Okay, great. So you're told that the arc length is given by this formula. So let's see how we can do this properly. I think before that, we're just going to just understand the curve first, because now you're told to find the total length of C. First thing is look at your GC. So always check by the boundary condition, because theta is from, look at the question. The question states that theta is from 0 to pi, right? So just try and trace 0 and see where is it at. It's here. So this is 0, 0. So this is actually 0, 0. Okay. Then when it's 2 pi, likely is this point here, but never take my word for it. But just this is likely is pi. Sorry. So just trace, calculate, put pi there. Trace pi. This is 2 pi. Okay. So and then we check your value there. So when theta is pi, you know that x is equals to 2 pi minus sine 2 pi. Sine 2 pi is 0, so this is 2 pi, okay? So first thing is just to understand what's a curve C, the boundaries of the curve there, before you even start doing it. So the arc length is given by this formula here, which is actually beta gamma square root of dx d theta square plus dy d theta square d theta. Okay, great. So find the total length of C. So this part here, what you're gonna get is actually just try and understand this part. So where theta is beta between two arc lengths. So this part here is theta equals to 0, and this part here is theta equals to pi. Alright, just be sure. Okay, theta, the parameter is invisible moving force behind the parametric curve. So theta equals 0 corresponds to 0, 0, and 2 pi, theta equals to pi corresponds to 2 pi 0. Yep. So let's try and see what we can do. I think it's pretty okay, because what we need to do is just put the dx d theta inside. Dx d theta is 2 minus 2. So dx d theta is actually 2 minus 2 cosine 2 theta. Then dy d theta will be 4 sine theta cosine theta. That's pretty okay. So just put into this expression here. This part here, what we're gonna do is actually gonna get 2 minus 2 cos 2 theta square plus 4 sine cosine 2 theta square. Actually, this could be simplified. I think I will simplify this to 2 sine theta cosine theta. This is 2 sine 2 theta. I think it's probably easier. We just do that to 2 sine 2 theta. Okay. Because I see that this is double angle as well, so I do not want to have too many gibberish inside. Then after which we talk about the boundary condition here. Now this boundary here is important. Sometimes students get confused. Remember that it corresponds to this d theta, so this should be theta 0 to pi. That's about it. So you just put 0 to pi here. So I think generally once you get this part here, you already secure about 2 marks. Yeah, because writing the boundary condition, applying it, and understanding it. Yeah. So then the next part is to try and expand this and see how this goes. Okay. So this part here will just be, expand this will be 4 minus 8 cosine 2 square plus 4 cosine square 2 theta plus 4 sine square 2 theta. So these two could actually be 1. So this 2 is actually 4, because cosine square 2 theta plus sine square 2 theta is equals to 1, right? So this is actually 1. So be 4. So so many things, right? Minus 8 cosine 2 theta plus 4 Okay. You could skip step if you want to, but I'm trying not to skip too many steps here. So this is 1. This is 1. Okay, so that's 1. So that will be 8 minus 8 cosine 2 theta. Okay, d theta here. Then once this is done, we get 8. Then this is 8 1 minus cosine 2 theta d theta. Obviously 1 minus cosine 2 theta, we could change it using the double angle and hope that we get something out of it. I will 1 minus 2 sine square theta again. Basically this is 2 sine square theta is equals to 1 minus cosine 2 theta. So we could just simplify this into the root 8. I'll bring it out. Alright, root 8. Bring it up. This is 0 pi root 8. 1 minus cosine 2 theta would be 2 sine square theta d theta. Okay, so root 8 could root 2 could bring it out as well. So root 8 times root 2, 0 pi. Oh, you get a very simple sine theta here. So this is root 16, 0 pi, and this is sine theta d theta. Yeah. So this is 4, and this will just be negative cosine theta pi 0, and this will just be 4 negative cos pi minus cos 0. Here you go. Cos 0 is 1, cos pi is negative 1, so you get 4 negative 1 minus 0 is 1 minus 1. So this will just be 1 plus 1, which is 8. So 4 plus 2, which is 8. Okay, units. Yep. It's not. I think it's not that difficult once you understood the terms properly, deciphering it. All right. So keep practicing. Any question or comments, please do let us know. See you in the next question.